Let's see if she pops in. So we're going to be doing hyperbolas. There's two different sections on hyperbolas. So we have an instruction, quiz, all of that, and then it's a continuation. And the differences between the two sections are going to be everything we do right now is centered at the origin, where the next ones we're going to do these hyperbolas that are not at the origin. And if we remember hyperbolas, the cones, they're basically, when we had our double cone, when we sliced it so that it made two parabolas. Like double cones, the cones went out like this or separately. And so cut through both pieces of the cones. And so that's how we end up with what we call a hyperbola. Now, a lot of the stuff that we're doing with all these different types of conics have a lot of similarities. And so I went ahead and put down all the formulas for both of these things we're going to cover. So if you guys want to get them down, these are going to be like everything you need to know for this section. So the difference between the two is, notice that this case, the x squared's first over my a squared, and then it's minus something, where this is a y squared first over my a squared. So the a squareds are always first, just like ellipsis. In this case though, the difference again, x squared first here versus a y squared first here. X squared is first, then they're gonna open along the x-axis. So they're gonna open, so it includes the x-axis. Here, when they open up and down, they're going to include that y-axis. They've got to go through that y-axis at some point. So that's going to be the differences between the two. An ellipse had a plus in between, where when we talk about a hyperbola, it has a minus in between. So there's some other information that we have. And so again, when I said everything is going to be centered at the origin, we're talking about this piece is the center. So it's in between my two vertices. So the parabolas have vertices. Each parabola has a vertex. And then something that they don't really talk about in this section, and when we usually teach it in school, we usually, I usually teach you guys how to graph it using the covertices. So when I talk about this, we usually have our covertices. So I'm just going to label them here. And when we talk about this, we usually create what we would say is a box that would connect all these values. When we graphed our ellipsis, we talked about things were from our center to our vertice, it was at distance of A. Same thing here, whatever this A is, that's gonna get me to my vertices here. This A value is gonna get me to my vertices. To my co-vertices would be my B value. Same thing we just did with our ellipsis. This is my B value there to get to my co-vertices. The reason why we drew these boxes is because when we would connect corner to corner, I could create this line here, and it's a dashed line. It's a dashed line because we say that this is a asymptote. So that's these asymptotes that we're talking about. And again, I would have it from corner to corner, and I have my asymptotes. Now, if I wanted the equation for this asymptote, it's at the origin. So remember, equation of a line, it's rise over run, or like it's going up and over. I could count my slope. I could count up and over. So in this case, if I counted up, it was a value of B over a value of A, right? Because this is a distance of A. And that's where this equation comes from. Different than over here, if I created my box, I would go up a value of A and then over my B value. So it'd be A over B. So notice the differences. But really, I'm just creating the slope of this line and these asymptotes. Now, if you guys remember, asymptotes are lines that you could never cross. So when we talk about these two parabolas or hyperbolas, they're going to get super close to these asymptotes, but never cross it. And that's what helps us get our shape right here, is these asymptotes. The other thing that we had when we had our parabolas was we still had our directrices. When we had our ellipses, we still had our directrices. And they were going to be our C distance away from our vertex. So remember, inside our graphs are always going to be our foci. Inside the parabola is always our foci. Inside the ellipse are our foci. On the outside are going to be our directrices. So in this case, we would have directrices here, and I would have a directrice somewhere around here. And here's our equation. So in this case, my directrices would go horizontally. It would go horizontally, and here's the equation. So we've got foci still, is still a distance of C away from my center. So foci is still going to be a distance of C away. We have our vertices, our directrices. Before on our ellipses, we said that the directrices had to be perpendicular to the major axis. We have an axis here too. They don't call this the major axis, but the axis that our vertices and our foci are on. This is what we call the transverse axis. That's our transverse axis. And so from vertex to vertex, that transverse axis is a value of 2a. So on our ellipsis, we said it was the major axis. This case, it's called the transverse. What else do I have to give you guys? Ooh, can't forget. C. I'm sorry, it's loud. C. When we talked about ellipses, ellipses had a plus here in between. So when we found our C squared, it was a minus. In this case, when it's a minus, our C squared is equal to A squared plus B squared. So they switched. Ellipses, it was a plus here and a minus here. Hyperbolas, it's a minus here and a plus here. So be careful because they are two different values here. We were using minus, now it is a plus. Questions before I actually move on, because there's a lot of all kinds of stuff here, but I'll get into some of the problems. So when I reference things, it's all going to come back to this information right here. This is everything you need to know for this section. Okay, so I'm going to go on to our first example. Okay, so things that I know just from looking at this. I know that this is going to be my center. It's directly in the middle of the two. This is a vertex because my graphs are always on my vertices. I know then that this would have been my co-vertice. I know the distance from my center to my vertex, the difference from my center to my vertex is my A value. I know the distance from my center to my co-vertex is my B value. And I know the distance to, these would be, I'm assuming they're going to have those as my foci, my focus of the hyperbola. The distance from my center to my focus is a C value. Different than this, I labeled this center as my C. So this is just C for center, not that C value up here. It opens along my y-axis. So I know my y value is going to be first. So I know that this is a y squared over, it's always a squared. It doesn't matter which one's bigger. Ellipsis, it was always the bigger one was first. Minus an x squared over some b squared is equal to 1. So what is it asking? It says the length of the transverse axis is how many units? Transverse axis goes from vertex to vertex. So this is a distance of a, and in this case, a is 8. Yeah, my center is at the origin, then a is equal to 8. So my transverse axis, remember it's 2a, is going to be 2 times 8, which is 16. Blank is the focus of the hyperbola. So it's a drop-down menu. So there's actually two. There's 0, 17 and 0, negative 17. The answer that they have for you to choose from is 0, 17. So there's two of them, but they only give you one option to actually select, one correct option to choose from. And it says the vertex of the hyperbola is located at, and same thing. You have two of them given to you, but you only have one correct option to choose from. So in this case, it was going to be your 0, 8. If I go too fast, let me know. All right, my next one. Graphing. Okay, so first thing is, it's an X first. So I know since it's X first, I know that it's going to open along my X axis. I know it's going to be something like this. This is going to be the direction because it's my X's first. Let me zoom in there. Let's see if we get a better view there. Okay, so what else do I know? So it says, what is the orientation of the transverse axis? Since it's going to open left and right, the orientation is going to be horizontal. And this one goes through different steps. So I'm just going to kind of work it out with you guys. So first thing is I know that my origin, all these are going to be at 0, 0 because there's nothing with my X or my Y. So that's where I'm going to start. I know that A squared is equal to 4. This is my A squared. This is my B squared. So if A squared is equal to 4, then A is equal to 2. That's going to give me my vertices. So from my center along the x-axis going left and right, because it was x first, I'm going to count 2 to the left, and that's a vertice, and 2 to the right, and that's a vertice. So this is my center. B squared was equal to 1. So B is equal to 1. That's going to give me my co-vertices. Okay, so if I create this little box, I like to create this box. They don't necessarily teach it to you guys this way, but I like to do this because what's interesting is when I create this box, if I go from corner to corner, this gives me my asymptote. So my asymptote is going to go something like this. There's going to be one asymptote. My other asymptote is going to go again corner to corner. I'm going to turn my paper just because it's easier for me. Ish. My lines are not super straight. So these created my asymptotes, and I had an equation for my asymptotes. It will say like, what is the slope of your asymptotes? So in this case, it's plus or minus B over my A value. So I could look at it here, or remember, it's just if I'm here, it's my rise over my run. So I go up 1 over 2. That's all it is. So it's just going to be plus or minus up 1 over 2, or 1/2. All they want to know is the slope of this line. So it's corner to corner from when I create my box, or I can use the equation, whatever you prefer. So I like to draw my asymptotes in and then sketch my graphs. That's because I'm going to be along my vertice. I'm always going to have my vertice here, but then the sides of my graph are going to follow my asymptotes. That's going to help me give my shape of my asymptote, or sorry, the asymptotes are going to help give me a shape of my parabolas for the hyperbolas. So I could go ahead and just follow along my asymptotes now for my graph. So once I have them, these are just going to go parallel to or along the same way as my asymptotes. The other things that they'll ask for is where are your foci and where are your directrices. So my foci, I need to know what C is. It's always C distance from my center in the same direction as my vertices. So it's always going to be on my transverse axis. So if I need to know what is C, C squared is equal to A squared plus B squared. So C squared is equal to 4 plus 1. C squared is equal to 5, then C is going to be equal to the square root of 5. Square root of 5 can be hard to graph, so I know that that's a little bit more than the square root of 4, which is 2. So I'm going to go a little bit more than 2. So you can plug it in the calculator and approximate it, but it's just an approximation on your graph here. So I'm going to say it's, I don't know, it's approximate. I'm going to say 2.2. I don't know exactly. It's somewhere in there. So if I go here, I'm going to count 1, 2, and a little bit. And there's a foci, and then I'm going to count 1, 2, and a little bit, and there's a foci. So how far exactly is this distance here? This is going to be my C distance, which is the square root of 5. So where is this point? It's my X value, it's going to be the square root of 5. My Y value is 0. Oops, that's a negative for this one. This one was at a positive square root of 5 and 0. So when I graph it, I'm just kind of approximating where it's at. The exact point, though, is that square root of 5 distance away from my center. The last thing we need to cover is going to be our directrices. Our directrices are going to be X is equal to plus or minus A squared over C. Should be very similar, that A squared over C, because that was the same for our ellipsis, right? So it's going to be plus or minus, my A squared is 4 over the square root of 5. 4 over the square root of 5. I could plug that in my calculator. So I know it's going to be an X equals, it's going to be plus or minus 4 square root of 5. And it's going to be approximately in here. Now these are lines, so I don't need to have it as a coordinate. Here we had to write them as a point. Here it's an equation of a line because their lines are going to go up and down. Remember that these lines here are always, my directrices are always going to go through my transverse axis. It's always going to be perpendicular to my transverse axis. So very similar to our major axis, they're always going to be perpendicular. Questions, because that's a lot to take in, a lot of different steps. All right, then I have one more problem for you guys. So this one, they gave us the centers at the origin. So that's the common theme for all of this right now. And we have a focus here, square root of 74 over 0. So remember, this is going to be my focus is this is my C value here. I also have my asymptote. So when we talk about our asymptote here, here's my equation. It's an X first. So it's going to open along my X axis. So if it's going to open along my X axis, then Y is going to equal plus or minus B over A. X is going to be my asymptote here. So if that's the case, then this has to be B and this has to be my A value. Okay, so it asked me, what is the equation? What is the equation for the hyperbola to make this work? So they want to know what is A and B. So I'm like, well, it's just right here. So it's just going to be my A is equal to 5 and my B is equal to 7. And you guys are like, yeah, it's just right there. So why do I need this C? Here's where you have to be careful. Here's where I need my C. Because what if I had Y is equal to negative 14 tenths X? Would I leave it like that? What if my B was 14 and my A was 10? Would I leave my answer like this? No, we would simplify it to Y is equal to negative 7/5 X, right? These are equivalent, but this is always going to be the simplified version. So it may not be that this is automatically my A value and this is automatically my B, because it could be simplified. So how do I know? Well, you would have to check. So if my C squared is equal to my A squared plus B squared, then I'm good to go. But maybe I might need to multiply those values by value of 2 or a value of 3 to get the right answer. So this is my check. Does 5 squared plus 7 squared equal my square root of 74? So in other words, 25 plus my 49, the C squared is going to be 25 plus 49 is 74. If I take the square root, C is equal to the square root of 74, and that's exactly what we needed. So since this is true, these are my A and B values. If this was not true, then I might need to double these values, or I might need to triple them to find the actual values. So in this case, my answer is X squared over 5 squared minus Y squared all over 7 squared is equal to 1, or you could have it as X squared over 25 minus Y squared over 49 is equal to 1. So that's what they were looking for here. Be careful, because sometimes they might trick you on this and use a non-simplified, they might have something that's simplified when your answers actually weren't simplified. Questions on that? All right, well, Monday I will have problems from the assignment, which will obviously cover more examples. And then Tuesday we will do quiz. So we've got a lot more coming. So good luck with the instructions today. If you guys need anything, feel free to reach out to me throughout the day. I'll see you guys. Have a great weekend. Bye. Thank you. Thanks.